Hi class, in this video we are going to create a probability distribution for the sum of two dice rolls. So you'll notice first off that we have two tables here. The table in the middle is already filled out for us, and this table is representing the sample space for the sum of two dice rolls. This is a table you probably are already familiar with, and we're going to use that table to fill out the chart on the right, which represents our probability distribution. Okay? So take a minute to pause if you need to go and review that table of the sample space for the sum of two dice. Okay, so now that you've done that, let me take a minute to review some aspects of this table here. The top row and the leftmost column are going to represent the dice rolls, okay? And then the entries that come after that first row and that leftmost column are going to represent your sum. All right, so those are all the sums of the two dice rolls that you got. So if in the leftmost column I see a 1, and in that top row I see a 1, where that entry, those two entries intersect, I should see a 2 because 1 plus 1 is 2. Okay, so again, I'm going to use that table to fill out the table on the right. Now, you might need to ask yourself, if you maybe have to create the sample space for an example that you're working, how do I know that my table is complete? How do I know that I have all the possible sums? Okay, well, now that we have talked about chapter 4 a little bit, we can use the multiplication rule and counting in order to see that we have everything included. All right, so to do that, I'm rolling two dice, so that means I have two events that I'm working with here. The first event is I roll the first dice, and that dice has 6 sides, each with a distinct number, 1 through 6. So that means I have 6 possibilities for the first dice. For the second dice, it's the same thing. I'm going to, again, have 6 possibilities for the second dice. So with the multiplication rule, I multiply 6 times 6 to get 36. And if you were to look again at that middle table and count up all of those sums, you would have 36 sums, all right? So now we can use, now that we know that our table is complete, we can now use this information to complete our probability chart on the right. So let's talk about our probability chart for just a second. Notice that you have 2 columns here. X is going to represent our sum. Okay, so X, these X values here, 2, 3, 4, 5, 6, all the way to 12, these represent the possible sums of our dice rolls. And then we have a P of X column that's not filled out yet. These are going to be probabilities. P of X, probability of X. All right, so then to find the probability for each one, I'm going to look to see how many times in my sample space chart, how many times each of those sums shows up in that table, okay? So let's start with X equals 2. So what is the probability of getting a sum of 2? I look at my table and I see that 2 shows up once in that table. Again, I am not going to include that leftmost column in that top row, okay? I'm just looking at the sums, all right? So I have one entry for 2, so that means I have 1 out of 36 possibilities. So the probability of getting a sum of 2 is 1 out of 36. To find the probability of a sum of 3, I'm going to do the same thing. I find how many 3s there are in my sample space. I have 2 3s out of 36, so the probability of 3 is 2 out of 36. Similarly, the probability of 4 is 3 out of 36. The probability of 5 will be 4 out of 36. The probability of 6 is 5 out of 36. Probability of 7 is 6 out of 36. All right, now you might get lazy and say, well, the probability of 8 must be 7 out of 36. But let's actually count. Notice that when I find the probability of 8, those probabilities start going back down because I only have 5 ways to get a sum of 8. So the probability of 8 is back down to 5 out of 36. The probability of 9 is 4 out of 36. The probability of 10 will be 3 out of 36. And the probability of 11 will be 2 out of 36. And the probability of 12 is 1 out of 36. Now you notice that I did not simplify my fractions, and that's because you'll see a little bit later that when you add up these entries in your P of X column here, these should all add up to 1 in order to be a probability distribution. So it's easier to add up these fractions when they all have a common denominator. So if you were to add up all of the entries in your P of X column, you would get 36 over 36, which does simplify to 1.